Hello 1166, how y'all doing? I'm Ryan Ortiz, the designer of the pulse monitor circuit, and I'm here to walk you through every step of how to build the circuit, how to code the circuit, and how to set up everything so you don't run into any issues at all. I'm going to walk through the whole process so it's crystal clear, and if you have any questions by the end, feel free to leave them in the comment section below, or just ask your TA. With that out of the way, let's dive into how to build and code the pulse monitor circuit. Before you start, quickly double check you have all of these supplies. One breadboard, 2 solar panels, a 1K resistor, a 10K resistor, a pulse sensor accessories, a microcontroller cable, a thermistor, a transistor, a potentiometer, an LCD screen, wires. If you have all of that, we can move on. Alright, so let's get started on building. First, I'm going to take my transistor, handy dandy, right here, and just place it down with the head facing this way. Next, I'm going to take my 1K resistor, place it down here so it can connect this LED I have. Where's the LED? Here it is. So I can connect it to the output of that transistor. Next, to the center signal pin of that transistor, I'm going to connect this 10K. And to the input of that 10K, I'm going to connect the pulse monitor signal here. And then I'm going to have that pulse monitor powered in these power rails right here with power and ground. And then finally, I'm going to give the LED some power. So we have these 2 solar panels right over here. As you can see, they're hooked up in series. Right? We have these 2 connected here, and we have these 2 power pins left over. All I'm going to do is I'm going to take a wire, hook it up to negative, positive, connect the negative pin over to the negative rail, connect the positive over to, well, actually the power rail of the transistor. The transistor has a power input, which is its first pin, signal input, which is the second pin, and an output, which is the third pin. Now, before we're all done, we of course have the matter of powering on the pulse sensor. It's not blinking green, and neither is our microcontroller, because we haven't plugged either of them in yet. So let's do that. I'm going to plug in these 2 jumper wire cables from the breadboard over to the microcontroller. We want to connect that to ground and 3.3 volts. Now, why 3.3 volts? Well, this breadboard works on 3.3 volt logic, meaning if we try to measure a signal with this that is greater than 3.3 volts, it'll just short out the signal. In brief experiences, it won't cause any damage, but long term, as long as this class runs for, it will eventually kill this microcontroller, which we don't want. So, better to keep it at 3.3 volts and not 5 volts. Lastly, nothing's blinking right now, which means time to plug in the microcontroller. Let's plug that in. And everything's coming to life. We can see it blinks when I put my hand down on it, but not really consistently. We need a better way of attaching this to my finger. This is where all those Velcro accessories we had came in. This little Velcro circle, it goes right on the back of this. This Velcro strip latches on to that Velcro strap. Other side. There we go. And now, with all that attached, I can just wrap it around my finger pretty tightly. And now I have a pretty consistent signal. If I look over to the LED, adjust my finger a little bit, Once you have it adjusted properly, you should get a pretty clean pulse signal. There we go. Think I got it. I don't know if you can see it blinking on your end, but to me, that looks pretty good. All right, now let's get on to coding it and how to actually take a signal from here and plot it on the computer. Okay, I believe we have started both captures at the same time. So, welcome back to the computer section of this tutorial. Really quickly, we're going to go over how to install Arduino IDE. Then we'll move on to the software part. First, this is an IDE. You code in here, and there's different models for each of your OSs. We have Windows, Linux, Mac OS. Choose whichever one is best for your device. When you click download, I'm not going to click it here because I've already clicked it several times. As you can see here, it'll give you an exe file. You click it, it'll ask you to accept a license agreement, to give it admin privileges, or just user privileges, depending on how accessible you want the app to be. And once that setup is all said and done, you can type in Arduino IDE into whatever task bar you have, and it will show up as an application. When you hook up your board, you're going to notice that this section here that says Adafruit M0 Express, that's not going to be there. It's actually going to say select other board or unknown board, because this isn't default in Arduino. So I'm going to show you how to import it so that when you type in Metro Express M0, you will get this response to this USB drive. So let's get started. First, you're going to go to File, go to Preferences. In Mac, this is referred to as Settings. All the way on the bottom, you're going to see this JSON file. It's going to look like this, completely blank and empty. You're going to copy and paste it in, click OK, and it's going to download the library that has all these files. You'll see a pop-up show up on the bottom right that's going to say, we're downloading these drivers, these boards, these packages. So just let that all load through and fully download. Once it's all done and downloaded, you'll want to go over here, click Select Other Board and Port, type in Metro M0 Express. Select this option, have this port selected. The one you'll be able to tell that this is the microcontroller port because it'll say USB in parentheses. Click OK. And now everything is set up so that you can upload your code to the microcontroller. Wonderful. Now that we have everything set up, let's start by just writing our code. First, we're going to start by starting up a serial terminal. We want to output data, right? Data from our pulse monitor onto the screen. Serial monitor is exactly how we do that. We start the serial saying we're going to send over a max of about 100,000 bits per second. Then all we're going to have to do is print those bits. Print line new, and then let me actually read from the pin using the analog read function. I'm going to read from pin A0. This will give me a value between 0 and 1,000, and I'll print that out to the serial monitor. Next, I'll just add a delay function. Since this is in void loop, this will loop forever, and I don't want this printing every 1 microsecond. I want to actually delay it so it doesn't fill up my terminals too quickly. I've heard from many groups that 20 seconds is the sweet spot. All right, this all seems good. Our microcontroller is plugged in. Everything looks ready. Let's verify our code. Okay, let's upload our code. Oop. All right, perfect. Now that all of our code's uploaded, we can open up Serial Monitor. On the top right, you click Serial Monitor. You'll see that these are all the values it's reading from the pulse sensor. If we put our finger on it and let it rest for a bit, we'll eventually get a proper signal, like so. Now, this isn't much to go off of, so actually we use a serial plotter to properly graph all of these into a much more recognizable pulse wave. Now, I'm going to open the serial plotter, but I'll have to stop the recording, so I'll be right back. Now that we're back, let's run the serial plotter, and let's start reading all that new data coming in. Oh, has such a clean waveform. We have a large pulse, and then a smaller pulse, and then a leveling out. Wow, so consistent, so clean. It was very much worth the setup. I hope this helped you set up Arduino IDE and helped you upload the code with the confidence that it won't break. It takes a bit of installation, a bit of setup, and a lot of installing new packages that Arduino tells you. Sometimes Arduino will pop up and say, you should install this package. And in all honesty, you probably should. I always trust Arduino whenever it tells me to install anything. I haven't installed any malware yet, so means that Arduino's got my back. So that's about it. We got the basic circuit working, we got Arduino set up and running our code, so should be smooth sailing from here. Alright, well that's it from me. I hope you take care and have a wonderful rest of your day. And if you have any questions, leave them in the comment section, or you can send them right to me. My email is ryan.r.ortiz@uconn.edu.